standard form of our quadratic function is f of x equals ax squared plus bx plus c, where a cannot be 0. In this expression, this term right here is called the quadratic term. And this is important, guys. What makes this a quadratic function is that x squared. If we don't have an x squared, if x squared is not our highest exponent, then we don't have a quadratic expression. We have something else. This is called the linear term. All right? Because if for some reason we no longer had the ax squared term, we'd be just left with bx plus c, and bx plus c is a linear expression, just like mx plus b is. All right, so letter C is called the constant. Constant. It's like 5. It doesn't change. That term is not changing anything. Plus 5. If x is 7, it's still plus 5 on the end. There's no x involved with that term that's going to cause it to be changing or moving. That does something to the graph overall, but it's not. It's a constant change. It's not a linear change. So we got linear change here, quadratic change, and constant change. All right. Now, so standard form of a quadratic function is f of x equals ax squared plus bx plus c, where a cannot be 0. Now, b and c can both be 0. I don't need those two terms to have a quadratic expression, right? All I need is a quadratic term to have a quadratic function. I don't need the bx, I don't need the c. So only a can't be 0 in this expression. All right, here's an example of a quadratic expression, or we're supposed to determine whether this represents a quadratic function. Is it written in standard quadratic form?
No.
No. Could we write it in standard quadratic form?
Yes.
How would we do that? Solve for y, right? Quadratic function is y equals ax squared plus bx plus c, or f of x equals ax plus bx plus c. To solve this for y, what would you do? Subtract 7x from both sides, and that would give us
4x squared minus 7x minus 6.
So this is definitely a quadratic expression, right? What is my quadratic term? 4x squared. What's the linear term? Negative 7x. Remember, the sign goes with the number, and the constant here is negative 6.
This is kind of.
It's really not that difficult. Our lesson today is pretty straightforward. What about this? Is this a quadratic function?
Nope, because it has no constant.
It has no quadratic. It has a constant. It has a b. So what is this? What kind of function is this?
Like a line.
It's a linear function. Yeah, y equals mx plus b. We could write this in slope-intercept form, y equals 2x plus 5. So that's a linear function with a slope of 2 and a y-intercept of 5. It's not quadratic. All right, what about this one?
Okay, we need to put this in regular form.
Do we?
No, actually, because it has no constant.
It doesn't have to have a constant to be quadratic. X squared isn't the highest exponent, right? Can a quadratic have an x cubed in it?
No.
No. We can't. Now, if the x cubed would somehow subtract away or go away when we made some changes to this, then we could still have a quadratic expression. But we don't. All right? We can't make the x cubed go away. This, we haven't defined this yet and may not in Algebra 1, is a cubic function. Okay? It's a cubic function, because it has a cube in it. Quadratic expressions have to have their highest exponent. Now, this does have a quadratic term in it, but the square has to be the highest exponent in order for us to have a quadratic expression. All right, now, this is very important. The graph of f of x squared, f of x equals x squared, is known as the quadratic parent function. It's the stripped down, simplest version of a quadratic equation. Y equals y equals x squared. Okay, graph the parent function by making a table of values, plot the points, and connect them with a U-shaped curve called a parabola. All right, a parabola is the graph of a quadratic expression. And you can see over here that when you fill in this table of values, you don't have to write this down. I just want you to pay attention to it. We're going to do another one on our own. When you graph these points from this table of values, 0, 0 is there, 2, 4 is here, 2, 4 is there, 4, 16 is not on the graph, and 1, 1 is not in the table, which is kind of odd, but all right, I can't get it to graph, but anyway, 416 would be somewhere way up here, but it's also in the graph of the parabola, and then the points on the other side. But when you graph this, you get a nice U shape. This graph looks very different from y equals mx plus b, doesn't it? Y equals mx plus b is a straight line. As soon as the exponent gets higher or lower, higher than 1 or lower than 0, then we've got curves instead of straight lines. Linear functions have x to the first power. Every other function is going to have some curves or is going to have some points in it. What I mean, not by points, xy points, but sharp points. Like we can have this. It's not really a curve. It's two straight lines, right? This is what the absolute value graph looks like. Okay. So absolute value is not a curve per se. It's two line segments. All right. So the quadratic graph has a distinctive shape. Its shape has its own name. It's called a parabola, just like a linear function has a graph that's called a line. It's the distinctive shape for the graph. All right, now let's use the same pattern and a table to graph this function, y equals negative 3x squared. And we're going to use a basic graphing technique. Check in, everybody. Where we choose values for x, plug them into the equation, and find a value for y, which generates ordered pairs. And when we generate ordered pairs, we have things that we can graph, right? Negative 3x squared is a little different from our parent function, right? Let's kind of talk about what the differences are. The parent graph that we just looked at, f of x equals x squared. What's different about this?
Negative 3.
It has negative 3 as an a value, whereas the parent function has 1x squared for the a value. So we're going to see something in this example that's different, right? Keep in mind that the graph of f of x equals x squared looked like this. And let's see what negative 3x squared is going to look like.
Did we graph this on a calculator?
We can, but we're going to do it in the table of values here. Let's use these values. And as a general rule, the higher your exponent is, the more points you need to determine the shape of the graph. All right. So when we were graphing lines and picking points, we picked 3 points. 2, you could make a mistake and not know it, but if you pick 3 points for a line, that's plenty to get the shape, because the shape of a line is boring. But with a parabola, we've got some shape to it. So we got to use multiple points, positive, negative points, 0. Always use 0 because it's easy to work with. And we're going to plug it in. Negative 3 times negative 2 squared is equal to what?
Negative 12.
Negative 12. All right. Negative 3 times negative 1 squared is negative 3. Negative 3 times 0 squared is 0. Negative 3 times positive 1 squared is negative 3. And then negative 3 times 2 squared is negative 12. So I want to point something out here that we have some symmetry that's taking place, right? On either side of 0, our points are mirroring each other. All right, -1, -3. +1, also -3. Okay, -2, -12. +2, also -12. So these points are mirroring each other on either side of 0. Now let's sketch a graph of this and see what it's going to look like. And I'm not going to be able to.
It would actually just look like a U.
But it's different than our parent graph, isn't it? Here's our parent graph, right? So we're going to. What I want you to see is the differences here, and then you can make some assumptions or come up with some ideas about what may be different. We got to go all the way down to -12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got 2, -12, and -2, -12. Right? I've got 1 and -3, and -1 and -3, and I got 0, 0. So the curve does this. That kind of curved back in. It's not supposed to curve back in, but it does that. Now, what's different about y equals 3x squared, -3x squared, and y equals x squared? What's different?
It's upside down
It's upside down.
and it's like thinner.
It's thinner. That's exactly right. It's skinnier. If you'll recall, on f of x equals x squared, let's kind of do this table up here. They use different values, but if we did a table for x squared, xy table real quick, -1 would be +1. 0 would be 0. 1 would be 1. 2 would be 4. Right? Where does this 2 go to? This 2 goes all the way to -12. This one's just 4. So it's not growing as fast. It's not as stretched vertically as the y equals 3x squared is.
Teachers, at this time, I'd ask you to release the band members if you have not already, so they can escort our basketball team. So please allow the band members to go down to the band room.
You guys will need to look at the video and grab your assignment from that. All right. There's a link to the channel on Edline. All right. So here's what we learned from this. Y'all watch. This is important. For a quadratic function in standard form, some of your questions on your next test are related to this fact. About 2 of them. Easy questions if you know this fact. For a quadratic function in standard form, y equals ax squared plus bx plus c, that's my standard form. If what does a is less than 0 mean? What does this mean?
Means though it's less than 0.
It's negative. Who said that? Yeah, it means a is negative. If a is negative, the parabola opens downward. That's like the one we just looked at, y equals -3x squared. I'm really trying real hard to decide why some of you would choose not to write this down. Don't be a lazy on a Friday. Let's finish on Friday. You can be lazy on Saturday.
And Sunday.
Not Sunday.
Yeah, not Sunday, that's the homework day.
A is greater than 0. A is greater than 0. That means if A is positive, the parabola opens upward. All right? And that's like our parent graph, y equals x squared. That opens upward because our positive A value of 1 makes it open upward. So in a parabola, A is the power player, right? A is the power player. It's really determining the shape of the graph. The quadratic expression determines the shape of the graph. The coefficient of the quadratic term determines the shape of the graph. It's very important. That linear term doesn't have a whole lot of effect on the graph at all because squares are more powerful than first degree terms. And when we get to cubic functions, guess what? The cubic term determines the shape of the graph because it overpowers the squared term. Okay, so everything will be determined by the cubic term in a cubic function. And that makes sense, right? It's the most powerful exponent is going to determine the shape of the graph. All right, so let's look at another example and just answer this question. Does this graph open upward or downward? Upward. Is it quadratic?
Yes.
Why is it quadratic?
X squared.
Because it has an x squared. Does this function have a linear term? No. It does have a what, though? A constant. It has a constant term, and it opens up because our a value is 3, positive 3, and that means the graph is going to open upward. If it were negative, it would open downward. What about this one?
It's negative. It opens down.
Why does it open downward?
It's negative x squared.
Because it's negative x squared, right? Our a value in this problem is negative 1. Now, this is not in standard form, is it?
No.
But does it have to be in standard form for us to determine if it's going to open up or down? It doesn't, as long as the x squared and the y are not on the same side. If the x squared term and the y were on the same side, then we would need to put it into standard form to determine the value of a, because it's only true that a determines the shape of the graph if it's in this form. Okay? In other words, y and the x squared term have to be on opposite sides of the equal sign. If I had y minus 3x squared equals 2x plus 4, is that a quadratic expression? It can be, right? It's not in standard form. So this is a quadratic, but we can't make a determination about this, whether it opens up or down, until I get it into this form. So when you add 3x squared to both sides, this one would also open up. But this one does open down because a is negative 1. It is not in standard form, but it's close enough to be able to tell whether it opens up or down.
So all we need to know is just if it opens up or down.
On these problems, that's all we need to know.
So we don't actually have to draw it?
No, you don't have to draw these. Now, in your homework, you will have to sketch a graph by choosing points like we did in that second example, negative 3x squared, but you'll just pick the points. Use the same points we used in class, and then sketch those graphs. All right, now, in our honors class, we're actually doing a project in the second semester related to quadratics, and it's related to this. Okay, a pebble is dropped from a 256-foot tall cliff. The equation 256 minus h equals 16t squared can be used to find the height of the pebble after falling for t seconds. Find the height of the pebble after falling for t seconds. So this is what we're going to do, find the height of the pebble. The first thing I'm going to do, and first thing you guys are going to do, is write down the original equation as it was given.
So we're doing the project too?
No, we're not going to do, and it's not this particular project. I don't know, we might be able to do some kind of a bonus project or something like that out of it. It's really quite interesting. This is the actual equation for projectile motion. If you fire a bullet into the air, if you kick a ball into the air, if you throw a rock into the air, when you shoot a basketball, has anybody ever noticed that the shape of a basketball shot is the same, right? It is a parabola. It is a parabola. It's not like a parabola, it is a parabola. Now, it might be a little skinnier, or it might be a little flatter, but it is a parabola because the force of gravity is negative 16 feet per second. So the force of gravity is a quadratic force. And so everything, the water coming out of a water fountain, when you press that ball, guess what that shape is? It's a perfect parabola because the force of gravity is a quadratic force. It is. All right, so when you press the water fountain, that's a parabola. It's not just like a parabola, it is a parabola. Now, not all arches are parabolas. Probably the most famous arch in the world is the what? It's the St. Louis Arch, and it is gorgeous. It's beautiful. I don't know if you've ever seen it. It is a marvel of engineering. It's not a parabola. The shape doesn't. It's a different kind of arch. It's not. You can model it with a parabola, and I've done a project with that before. But parabolas are a natural phenomena. Okay, every time you throw a baseball from the pitching mound, I mean, what does it do? It does this. I mean, the release point is up here, but it does this. And you can counteract that by doing spins and things that change the air around the baseball and cause it to move. But if you just toss a baseball, it's a parabola because gravity is pulling on it at 16 feet per second. 16 feet per second squared is the force of gravity. So if we're going to find the height, I want to isolate h. So if I subtract 256 from both sides, I get 16t squared minus 256. And how do I solve this for h?
Divide by -1.
Which is equivalent to just changing all the signs, right? Change all the signs in the equation. H equals negative 16t squared plus 256. There it is, gravity pulling on this pebble at 16 feet per second per second. 256 is the initial height or the initial position of the pebble, right? So to find this at this point, we would just plug h at time 2 seconds equals negative 16 times 2 squared plus 256.
Why'd you put the 2 by each?
Why did I? Oh, I just used function notation. I switched to function notation. You wouldn't have to do it that way, obviously. I just changed to function notation because height is a function of time in this case. Negative 64 plus 256 is what you get here. Negative 64 plus 256 is 192 feet. So after 2 seconds, it is 192 feet off the ground. It's really moving pretty fast if you think about it. After 2 seconds, it has fallen 64 feet. That's 21 yards. It's moving it. It's faster than anybody can run a 40. Gravity is very fast. We don't realize it, right? It's because it's just pulling on us all the time. That's why we get tired. That's why you get shorter when you get older. Gravity is pulling down on your body. All right. Here we go. Homework. Page 553, A through G, 1 through 7, 12, 14 through 17, 21 through 27, and 29. It would be a bad idea to do what Chase said and wait till Sunday to do this. It'd be better to get this done today so it's fresh on your mind. It'll be easier for you and more productive. Don't wait till Sunday to do your homework. Y'all have a great weekend and make wise choices.